Welcome back, Generals, to another Let's Fix Generals 0 hour to make the best game ever. Okay. So. Okay, I have a bunch of new changes here. Let me take a look at this one. And this one. Eliminates global lock contention in ASCII string system. Passed by value. Global lock contention ASCII string system. The lock in ASCII string needs to be replaced with an atomic rights. Mm-hmm. 1% low FPS metric. Okay. What? Pretty sure that this won't compile on VC6. I could be wrong, but I don't think so. Okay, let me look at the description again. Eliminates global lock contention. High contention. Unit heavy simulation steps. Wait. Which threats contending? Yeah, I'm confused by this. I would have expected all this logic runs on one thread only. Like the terrain logic, everything's one thread. So I find it a bit absurd that boosting performance from 14 to 87 FPS and the 1% lows. Okay, so for stuttering, okay. So it avoids some stutters, okay. Yeah, I was already wondering, like, in total, that makes no sense. Like, if this was average FPS, that wouldn't make any sense. Yeah. Okay. So in principle, I think it's pretty safe change, pretty straightforward. I'm just surprised that to avoid stuttering by this much. No. Yeah. So the only place, the only places where we see the removal of a reference counter change is here, and everywhere where we pass a ASCII string directly as a reference, as an argument. But all the functions that return, like this one here, this is not addressed, right? So if we now go here, okay, so okay, so there's no middleman, but here's a middleman. Here it creates a copy. Yeah. This change is incomplete because callers still make a copy. Well, let's say still writes the reference counter. Increasing ref counts. Let me double check that this is, yeah. This change, this pool needs more info. Where exactly the contention was observed with evidence. Performance. Minor. Okay. Author Mola. Mhm. What implements get extension, remove extension function. Okay, let me see the new code. Extension, okay. Find the Max PTR. Max PTR. Min PTR. Max PTR. Start. Can simplify to one line as last slash Max PTR okay. Type name PTR. Okay. Start. Okay, that looks correct. Okay. Yeah, I think it looks fine now, as far as I can tell. looks correct. Maybe there can be a follow-up in the future where extension search is placed with the new extension search. New functions. Okay. Okay. Let me look at Cabal. Did he address this one now? Location guards. The above code XFIS M target type indices 0112. 0112. Right. Which is out of bounds. Okay. If retake compatible CSC or retake compatible XFIS. I think this fix needs a version bump. Why is this? Griptire has a complaint. It's a P2 complaint. Unused Boolean argument, but it's called many times. It's called many times. Append message. True deletes entire group. Deletes a group. Deselect currently selected objects, which can be none. Deselect. It seems fine, yeah. Clear squad. This replay, let's see, replay, playback, still work? Let me go to a recorder class. Game message. Playback file. Append next command. new instance. Okay. Message. Read argument. Expected will still appends. But it perhaps makes sense to introduce a if we reduce this, if we remove this, then it will no longer be saved into the replay. And so loading this replay, yeah, well, it's unused, so it's safe. Yeah, it's probably okay. It's probably okay. Can a new replay written by this client still be loaded in the retail executable? Okay. So, okay, how about we get back to the code. Last session we did write the stuff here, and it did not work quite right yet. Okay, so what we did see is that the far Z is a bit too far now. Let's put a breakpoint in here. Yeah. So blah blah blah. Okay. So terrain half width is I wonder. Terrain half width. Okay. 1280. Okay. 770. Okay, that's actually a big loop. Oh, it actually is a very costly loop. Okay, maybe we need to increase the steps even more. Yeah. Okay, so at the end of that, we now have a left position, top, left, top, right, 75. Okay, I'm surprised that they are all at 75-ish. Left. Okay. Far point. The far point should be the far point should be the top edge, right? Top, yeah. No, it is the top. I think it's most of the time the top. Yeah. 3327. 4.8. point length. Okay, it's actually really far. It's really far. So why is it minus 70? And top is 2620. 2620. Then what's the height? 208. 208. But then it can't be 3000. How is this 3000 now? I don't understand. The Y here, are we missing something? Hold on. X is 250. X is 250. Aha. Why is this 1740? Shouldn't this be like aligned? It's because right, because we can be when we are at the edge. I see. I see. Yeah. What we can probably do is we just use Campos here. Then we remove this here. And then here we use, so instead of terrain half width, bottom right, we use here Campos X. Yeah. Top as well. Campos X. And then here left we use Campos Y. And here we use Campos Y as well. So that the edges are, so that basically we ignore, when we go to the top, bottom, left, right edges, we ignore we go in how do we say, like we make a right angle triangle. It's like straight line to the edge from the camera position. Yeah. So we only take the distance from the height, the elevation, plus the distance to the edge, straight. No left and right deviances. I don't know how to explain it. Yeah, let me make a graphic, yeah, so it's easier. So it's pretty small here. So let's say this is a map, yeah, and then this is the drawable terrain area, which is a square. Yeah, this is the drawable terrain. It's now colliding here with the bottom edge. And then the camera position, let's say, let's take a circle. The camera position is here. Yeah. And it's looking into this direction here. Yeah. It's looking this way. Yeah. And then now we sample the distances from this position to the edges, straight line, left and right, and bottom and top. And the furthest edge wins. The furthest edge, so the forward edge to the top edge, that's the longest distance, so that will be our far Z. Yeah? And no matter, even if we rotate the camera, let's say the camera is looking into this direction. Yeah, it's a bit angled. Then we should still sample in a straight line to the edge. And then this distance here, I may take another circle. Can we do that? No. So, well, that's not right. Wrong size. Maybe like so. No, that's also wrong. So this is the radius of the circle. So it needs to be twice this size. So this is 1, and let's say this is twice the size. Yeah. So far Z in all directions would cover this. No, is that correct? Yeah, well, if we look into this direction, then this box also changes. Then this box actually, if we look into this direction, then the red box, the terrain, well, we're colliding here with the edge right now, but it would then shift. Oh, it would shift to the side if we look to the side. So it would shift over like this, right? Wow. When we start rotating the camera looking to this direction here, then the terrain box will also move. Yeah, let's just keep testing it. So we have campus, Y, X, okay, right. Okay. Yeah, let's increase this to 16, yeah. Okay, now this one is unused, so that's cool. Yeah, this loop is a little bit unfortunate here because, yeah, it is costly, but the smaller the visible area of the terrain is, the faster this will be. So I expect that now the accuracy will be a bit higher. Let's say. No, it still is too much. Okay, let's put another breakpoint. So now we have top is this, what is far Z now? 3,160. Okay, so it's a little bit less, but it's still higher than what we expect, right? So the top edge, well, we can't see it now. So the top edge is at 2,650. And our position, CAMPOS, is at minus 55. So 55 plus this, so we had the 2,700. Z is 76 and CAMPOS Z is 226. So that should be just like a little bit, let's say 100 or so, yeah. So I don't understand why the far Z is over 3,000. It should be around about, it should be around about 2,800 or so. Why is it larger than that? Far point. X. Ah, because there's an X here. Ah. Right. We need to deduct the yeah. We need to deduct the CAMPOS from these here. So left minus equal CAMPOS. Is that right? But then we deduct a lot of Z. Is that fine? CAMPOS, left. CAMPOS. Or should it be the other way around? Left is CAMPOS minus left. Left. I'm not sure which order we should deduct. Let's go with the top edge. Top edge, deduct the CAMPOS all the other way around. Minus 55. Let's test it like this first. So left is that. Top right, and bottom. Yeah. Then one of these components should then be 0, right? And then now the origin point essentially will be 0. Yeah. Then what we can do next is we no longer need to do this, but we need to do left dot length squared. Okay. Then here we say len. I'll just keep distance. It's fine. Okay. Okay, let's test that. I'm not quite sure about the order of this right now. If it should be left minus campus or campus minus left. I'm not sure. Let's just test it. Mm-hmm. 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 So let's see. Left is now minus 170. Top. Okay. Right. Okay. Bottom. Okay. Bottom. Okay. Minus 310. Top. Minus 310. So left. Left. Right. Mm-hmm. Set left. I wonder if we should flip Z, but it doesn't really make difference for our distance calculation, whether it's negative or positive. Doesn't really matter. Yeah. Yeah, so basically it means that it was at 0, essentially. Yeah, I think it's fine. Okay, so now let's load again into DEFCON. Okay, this looks much closer now. Okay. It's still not quite right, but it kind of meets my expectation. Yeah, it's probably very accurate when we are very flat. Yeah. Yeah, okay, so it's not quite right yet, but it's very, very close. So that's cool. Let's see what happens if we rotate. Uh-huh. Yeah. Okay, it's definitely too far now. It's not too far here, but it's too far here in the edge because it is rectangle. Yeah. Yeah, it's a bit hard to say, like, how should we deal with this? I mean, you can't really. Like, the only other way would be to bring this further closer, right? Yeah, but maybe it's fine that when we are angled like this, 45 degrees, and it's just less accurate. Maybe it's fine. Yeah, I'm not so worried about that. I think the most important is that the default view looks acceptable. Yeah, the default rotation. Okay. Um, mhm. Okay, I'm surprised though that it clips this way. Yeah. Okay, so it is still a bit too far. Now, I think it's because right now it's a straight line to. It's a straight line from the camera position to the edge of the. To the edge of the terrain, to the lowest terrain. So the lowest is here. But probably we need to project it to the center point. Right? How do we do that? So let me ask ChatGPT. I already had such a chat started. Yeah, for clip length calculation. I would like to go with the sphere approach. I think we also need to I think we also need to align the far distance with the camera look at direction. How do we do that? Not as sufficient for perspective projection. Far clip angles along the camera's forward view direction, not radial distance. So you need to project the sphere onto the camera's view direction. Camera position, C, camera forward unit vector. Okay. Terrain bounding sphere. Okay. Radius. Project center onto view direction. Compute the vector from camera to sphere center. Project onto the forward direction using a dot product. Forward direction. Distance along the view axis. Huh? S minus C? Why that? I don't understand. What is center S here? What is this? what a center is. Eh? Okay, we can't get the forward unit vector. That shouldn't be a problem. Terrain bounding sphere. Well, maybe what he means is the... Maybe what it means is the position on the terrain elevation. Computer vector from camera. Okay, dot product makes sense. So we have... Okay, dot product actually, yeah, makes a lot of sense here. Then let me get the... transform. Campus. CamDear. Yeah, I think we need to pass CamDear here as well. This one is normalized plus R. Dot F. So here, camera transform, I think we need to get the Y vector. I think that's forward. Here we already have the forward there. Yeah, so this should be a unit vector. And then we have real scalar. Should be CamDear dot product. Is there no inline dot product? There is no static. Huh? I hear times. Dot. Yeah, let's do dot product vector 3 and dot product CamDear and far points. Do we have a normalized dot product? No. We probably need a no, that doesn't make sense. Hold on. We need that doesn't make sense. Hold on. What did it say? Decenter plus R. So let's say campus or far points minus campus say far points dear. We do that and then normalize. Okay, and then this times that. Does that make sense? I'm not sure. Let me put a breakpoint here. Oh, well, that doesn't look quite right. Assertion failed. Okay, well, that's not good. Okay, let's put a breakpoint in here. Okay, what is wrong? Oh boy. So it is looking forward a bit, and X is also. Yeah. It's a bit strange. Dot product. So looking there, and that's okay. Okay, it's a bit strange. Okay, so I think it's not quite right here. Cam deer. Okay, so camera is looking into this direction. Far point deer. Yeah, so that's very short. All right. Wasn't the get y vector, wasn't it minus z, the forward direction? Hold on. Camera class. Here, get forward there is minus z. Aha. Let's do vector 3, cam deer. Maybe that was the error. Okay, this is closer to 1. This makes more sense. Okay, this looks stable so far. Okay. Oh, well, that was way too short. Okay, but that's better. Okay, let's see. Oof, well, that's a bit short. Okay, but it actually looks correct. You see the fade is very close now to where the terrain is. Yeah, it's very, very close. We probably need to make it a bit shorter so that this... Yeah, it looks like it's the right distance now. But we probably should reduce the length, the far z, by far point deer. We should probably reduce it here. So high, and then here we say plus this. Yeah. Actually, no, this is high, so this is minus. And here we do plus. and here plus, and here minus. Mm-hmm. 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 Here we say sample the min z height along the bottom and top edges. Say roughly. This one is roughly sample along the left and right edges. And here we should say let's say const x per rear margin. Say a terrain margin. Mm-hmm. Then it's a bit self-documenting. Mm-hmm. Let's move this up here. Mm-hmm. Okay, I think this makes sense. Say here align to camera there. Line length to camera there. Direction. Align. I don't know how to describe this. Scale. I'd say a normalize length to camera direction. I don't know. Sample the furthest edge. This one is normalize edges. Say move edges to 0. Get let's say take edge, take one position at each edge. Mm-hmm. Okay. Good. I think this makes sense. Then let's see if that looks a bit better now. Mm-hmm. Mm-hmm. Okay, there's a problem is the far Z when we haven't updated the camera yet. So I need to look into that. Okay, but when I move it once, then it's okay. Okay, it still looks janky. Yeah. Ah, no, it's actually too much. Okay, now we can actually look too far. Did we do a mistake here? I know why this clipping happens because right. This margin, I think that's useless. Let's remove that. I think the problem is that since we sample well, maybe we already deleted that. Maybe here we need to get the what did we call it before? The terrain aligned campus. I don't know what I did call it before. Let's say a tile aligned campus. So Z is campus dot Z, that's fair enough. X Z. So it's campus divided by this times this, right? X, of course. Y, okay. Campus. But then we need to do this before already. So let's put it here. Then we put that here. Okay, tile align campus, blah, blah, blah. Okay. So we divide this by that. But we needed to make it a real int. I think we can remove that. Yeah, this might actually solve it. Error. Train margin. Basically, the far Z, it needs to move smoothly. It shouldn't have these strange movements. Yeah. This popping, I don't know how to describe it. Well, it still looks bad. It looks weird. Why is it pumping like that? It looks nervous. Okay, I'm surprised by this behavior. Let me put a breakpoint here. 1740 240. That looks also unexpected. Okay, there's still plenty bugs. Oh boy. Oh boy. That's a shame. Okay, let's clean up here a little bit. Yeah, so it somewhat works, but it also somewhat doesn't work. Great. Let me ask ChatGPT if he finds. So my current code looks like so, but it does not work quite right. Can you identify all potential issues? Let's see what it can come up with. Let's take this here, world type map. Few conceptual mismatches. You're mixing world distance, camera relative vectors, view space projection in a way that breaks the math. Great. Not actually using a sphere. You said you want a sphere approach, but this code samples 4 edge points, picks the farthest. That's neither a correct AIBB test nor a bounding sphere. It's a heuristic that can easily miss a true farthest point. Underestimate far Z, terrain gets clipped. Yeah. This part is buggy. Top distance. You're comparing against the wrong references each time. Do we? If top is larger left, you set far points. Yeah, but the next you compare right. Larger top distance, not against the current far point. That's a good point, yeah. So the max distance. Okay, I think that looks all right. Mixing coordinate spaces. Far point is relative to tile aligned campus. Then you subtract campus again. That's inconsistent. If effectively done. Far point is relative to tile aligned campus. By the way, this was only 2. Mixing coordinate spaces, major issue. Mixing coordinates. What's the problem? Okay, so everything is wrong basically. That's great. Um, hmm, that's true. Far point length measured from 0, 0. Uh, you only sample edges, ignore max heights. Yeah, that's fine. Minimum height, not maximum. Only tracks minimum height. Okay, so basically, it's criticizing everything that I did here. Not actually aligned with camera forward. What it should look like, let me see. Center. Yeah, but I'm not sure about this here. Hmm. Hmm. Okay, let me ask. Okay, can you rewrite it to what you think would be correct? It's show me. Clean rewrites. Show me. Convert to world coordinates. Estimate min-max height. Ugh. Bounding sphere. Sphere radius. Project onto camera forward direction. KMD must be normalized. Safety margin. Clamp. Okay, let me take this and let's test this, yeah. So we take all this, yeah. But this takes min z and max z across. Well, it's weird. So it takes it across the whole thing. There already is such a function with such information. So min z gets here max min height value. So we already have that. Then we don't need this here. But it's weird because don't know. To me, it looks suspicious. Radius. Project onto camera. Okay, let's test this. Yeah, I'm very skeptical about this. Yeah. Well, if it works, then the AI generated code is certainly smarter than I am. Yeah. Okay, so far it looks okay. Okay. Then let's see. Okay, that doesn't look right. Let's take a look at the value. Okay, it's too large. Yeah, it's too large. Why? So yeah, it takes a center position. Why would it do that? Half extends. Project onto camera forward. Center. Center. Camera. Decenter. It's not clear to me what it wants to do here. What happens if we rotate it? So it's a bit too far. Okay, let me ask. Far Z is a bit too far. Is a bit too far. What is wrong? Consistently too large. The mass itself is probably fine, but the bounding volume is too conservative. With the sphere approach, that's the most common outcome. Bounding sphere is inherently conservative. That sphere encloses the entire AABB. I would. Okay, I would like the sphere. I would like the radius to touch. I would like the radius to touch. I would like the radius to touch the edge of the terrain, of the tiles, not surround all tiles. Yeah. Breaks the usual bounding sphere assumption. I don't care. Yes. Okay, show me. Project center. Okay, what is the difference now? Does that make sense? I don't know. Projects. Directional radius. Okay, let's just test it. I have no idea if this is correct or not, but the code looks short. Much shorter than what I did there. Mm-hmm. 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 Okay, it's close, but it's not quite right. Mm-hmm. It is better. Yeah. Mm-hmm. Whoa. Gets really laggy when we go into this corner here. Whoa. 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 Why is the performance so bad? Does it call this? It does. Interesting. Interesting. Okay, that's very interesting. Okay, it's fine. Then we... Wow. Okay. It is calling this. Okay, why is it doing that? That looks like a strange bug. Yeah. It's continuously calling this when we are at the top edge for some reason. Huh. Okay. Let me put a data breakpoint on this one. Okay, that's really weird. Okay, here it's set to false, and then here it's set to true. Update camera area constraints. Area constraints. So to me, it sounds like someone is changing this one. Hold on. Okay, so this one fails. x, y. So y is 133, 1837. The top one is 3116, 81616. Yeah. Yeah. It's in region. Low x. We can't see low. False. Yeah. Okay, that's weird. X. What is x? 133, 183762. 762. Okay. So to me it looks like the values are exactly this and this. It's exactly in the corner. Yeah. And then what happens here? Clip apps. I think I see the issue here. So no, that's fine. Clamp. Low Y plus. Actually, that looks correct to me. Okay, I'm confused by this. It seems okay. We'll give a little bit of a margin here. Yeah. Maybe the epsilon needs to be larger. Maybe the epsilon is too small. Could be, yeah. How about we make the epsilon so the 0.1f. It's pretty big epsilon now. Okay, that was very interesting. Okay, it's still lagging. but only when we scroll into the edge. Not at the bottom edge. But it happens when we scroll into the top edge. Whoa. What the hell is that? Okay, at least it stops now when we stop scrolling. I wonder. I wonder if it happens because huh. Wow. It seems to be some other issue in the height map, I expect. Like we're not touching the edge now, and it still gets super expensive. But only there at the top. When we're at the bottom, it's now okay. It's now also expensive. The hell is that? For I haven't really seen this before. Hmm. Mm-hmm. Yeah. Hmm. Okay, so anyway, let's ignore that for now. Okay, so it is closer now, but it's still not quite right. Yeah. Mm-hmm. Still not quite right. Mm-hmm. This is better, but still does not perfectly align with the edge of the terrain of the rendered terrain. What is the problem? Very close now. AIBB is no longer the projection. It's a mismatch between the bounds you compute and the geometry you actually draw. My expectation why this is wrong is because the height, we use height Z now, min Z, so it's at 0. I mean, can we... this way. So So it purposefully takes like the middle ground. Let me put a breakpoint here. So 127. Oh, it's actually aesthetic. Oh. Oh, okay. I thought this was a. I thought there was some value stored somewhere where it stored the min max of the entire terrain. So the min would be 0 and the max for this map maybe 120 or so. Yeah. Okay, well, that's unexpected. Let me see an height map. Nope. Base height map. Here, get min height. Base height map. Base height map render object class. Okay, let's try this. I don't think this fixes it, but let's see. Center campus. I have the impression that the AI generated code is not quite what we like to do. It's still not right. Yeah. Okay, let me just the code now looks like so. The I'm not sure all this is correct for what we need. The 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 far Z needs to reach the furthest edge, the furthest visible edge, which typically is at the forward, which is at the end of the forward view direction. Yeah, so I don't understand why it takes a center. I don't understand this part. Why is it using the center? And then it takes vector center minus campus. Why? Then it takes dot product from this cam dir. I don't understand this here. Like, how is this correct? But it still reaches beyond that by a bit. Expectation is slightly off. Why? Far that should stop exactly at the visible edge. Yes. Why not? What you could compute is the furthest point of the terrain in view space Z. Of the terrain. Not the furthest visible point on screen. Not the same thing. The deepest point along the camera forward axis. Why this overshoots? Perspective projection points at the edges of the screen are not the deepest. Okay. The point that looks furthest away is often at the top edge of the frustum. Okay, but if we now go to the very tippy bottom, then it's still wrong. Why is this tree visible here? But the okay, the tree is closer to the edge. Let's look a little bit up. Yeah. Okay, but there's still a space. There's still blackness here between the terrain and the supply here. Yeah, why does it actually say plus here? What is this? No, it says minus here. Mm-hmm. 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 X. Mm-hmm. X. Mm-hmm. Yeah, we can probably remove this here. Mm-hmm. Convert to world coordinates. Bounding sphere. Mm. Mm. Project corners using view space Z. What? View matrix. Mm. 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 Yeah, that's fine. Terrain edge is curved, that's fine. Hmm. Okay, I don't see how this matrix thing here would solve anything. Hmm. 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 I don't know. Hmm. Hmm. I actually don't know how to implement this properly. Yeah, I'm confused by this here. I'm also confused by this here. Aligned with the actual clip space. Actual clip space. View matrix. What is this? Oof. What? Interesting. Okay. Okay, it's safe to say I don't understand the plan here of the AI. But it's probably smarter than I am, so I take that. Okay, why would the view matrix help here? Far plane is flat. View space Z of terrain corners. Frustum plane clipping. So view center equals that. Compute projected extent along view Z axis. Well, I can already see this failing because the view matrix that we have, it's the transform that we have, it's not in regular space, but in camera space. Right. Ugh, I don't know. I still don't understand why it overshoots. Then let me read that again. So what is P and what is C? It's a horrible explanation here. What is P and what is C? Camera tilted slightly downward. Yes. Terrain in front. The visual furthest point is near the horizon, top of screen. Yes, that's correct. But the point is at an angle to cam deer. Yes. Its dot cam deer is smaller than some other terrain point. So your code correctly picks a point that is deeper in Z. Deeper in Z. but not actually visible as the edge. Okay, I think we first need to fully understand this math down here before we can ask more questions. I still don't understand why it picks this center at the center of the terrain tiles. Then it takes these half extents. So that's the radius from the center to the edges. Yeah. Which should be the same for this. And dx dy should be the identical because it's squared. This one will be different. And then yeah, it has this vector from the camera to the center. Okay, and then we take this. So this one will be a value smaller than 1 but close to 1. And then no, it's not true. Directional radius. Huh. Okay, let me open it in debugger. So center. Okay, that makes sense. 645, 645, 79. Okay, fair enough. Half extends. Now we have the center point here and the camera position. So V will be here, looking somewhere forward, left, down. Okay. Then D center is 1379. Okay. And so 1300 plus 700, that's way too much, isn't it? Was that correct? It seems so much. Cam deal dx. Cam dx. To me, this makes no sense here. This R project. Like, why do we add all these things? I don't understand. What is this? Directional radius. Huh? To me, it sounds cheated, right? Because the center campus. Yeah, to me, it makes no sense because to me, it makes no sense to add decenter and RPROI to make a far that I expect that we get a distance from the camera position from campus to the furthest edge, not the center, and then align that on the it makes no sense. Then align that on the view direction, on the cam deer. Your intuition isn't wrong, but it's mixing two different ideas. Distance to a specific point versus maximum depth along a direction over volume. Yeah, but clearly the result that I'm getting from this AI generated code is not correct. So what is it? It's making up bullshit here. It's making me more confused. It has some concept of something, but it's not correct or not accurate. Center plus something random. Exactly the furthest point in the box projected onto CamDeer. How? Expect distance from campus to the furthest edge. That would be P minus C. But the far plane does not use Euclidean distance. It uses that. Projection of the view direction. Okay, I don't. Your terrain is not a box. Well, it is a square. Height range, inflates depth. Corners. Project the foreground corners. Corner projection. Corner projection. How would that help? I still don't understand. Okay, so what we can say is the AI code is wrong. My own code is wrong as well. Yeah, so we right now we just have a whole bunch of wrong code. Yeah. Now I would say that the AI generated code works more stable. The code that I wrote falls apart relatively quickly. Yeah, so it has that disadvantage. But this one looks more accurate when I just look forward. Yeah, so it has that advantage. But maybe that's just luck. I don't know. Um, yeah, I don't understand this part here where it just takes from the camera position, camera dia, and then multiplies by this, and then just adds it here. Like, why? Project center. Decent. Let me ask, should we perhaps do the dot product later? No. Rejected. Okay, let me try this then. Corners 4. Okay, let's try that. Which means we no longer do this here. Okay, but at least it takes corners now. How about we do how about we do this minus this times 0.5, so we take the center of these. Yeah. Yeah. Like so. Okay, it's safe to say I have no clue. Okay, it's still not accurate. Yeah, I don't like that either. Yeah, it sucks. No, it sucks as well. Yeah, I don't know. Is there maybe anything else we can do here? The corner projection overshoots as well. Any other suggestions? You're trying to match a far clip plane, a flat plane in view space to a curved project silhouette of terrain that cannot line up perfectly in general. So every method we have tried will systematically overshoot. It's not true. It's not true. Like if I look down, it should perfectly align here. Like the far Z, like because the look at is straightforward, and it lines with the terrain plane. Yeah, so this should work perfectly. If this is slightly off, okay, that's a different story, because we are angled. Okay, fair enough. But this one should be 100% accurate. Yeah, so I don't buy this here. What do you, blah blah blah. Deepest points, visual edge. What do you actually want? Furthest visible edge. Yes. The intersection of the center view ray with the terrain bounds. intersect ray AABB. Center view ray. Fog lot fading, horizon blending. Overshoot is fundamental. You're solving the wrong problem. I don't know. I'm not giving up here. Intersect ray. Don't we have such an intersection? Intersect AABB. No. Intersect. Intersection class. Here, intersect AA box. Test class. It's not much use of it. Okay, it has been almost 3 hours. I didn't make much progress. I don't understand this math here. For me, like, I had this differently in mind, that I would draw a line to the furthest edge and then align that with the view direction, and that would give me the correct distance. But somehow the AI thinks it needs to be different. Yeah, there probably is a way. Yeah. Okay, anyway, I will take a break here. Hmm. Then I wish you a great day or night. Until next time. Goodbye.